These 4 dice will be used in this presentation.
This green one has all 3s on it.
The green die has 6 3s. This yellow die has 4 4s and 2 0s. 4 faces of the yellow die have a 4.
So I need a volunteer. Rudy, okay. Now you pick out any die you want. I'm going to show you the, you can look them over and pick out one that you think is going to win all the time, and I'm going to pick out another one and we'll have competition. So,
Brody must select one of the 4 dice. It is a difficult decision.
you pick out the die you want.
Brody selects the red die.
Yep, what you think you're doing? Okay, you pick the red die. Now, what numbers are on the red die?
6, take 2.
How many 6s?
2 6s and 4 2s.
2 6s and 4 2s, so I've got all 3s on this one. Who do you think's going to win for the rollers? 6 beats the 3, doesn't it? But, okay, let's do the roll.
Brody rolled a 2 and lost the first round.
You got a 2 and I got a 3. Let's do 2 out of 3, right? You want to bet on it?
Brody rolled a 6 and won the second round.
You got a 6 and I got a 3. So it tied.
Brody rolled a 6 again and won 2 out of 3 rounds.
You won. Nice. Let's give Brody a hand. Okay, I want to show you these dice. All right, here I had 2 6s, and I had all 3s.
Brody has less than
A 50-50 chance to win because what's the chance that he's going to roll a 2? What's the chance that he's going to roll a 2? Yeah. What do you think? 4 to 6, okay? Now the fraction 4 to 6 in lowest terms is what? Two out of 3, right? 4 6 is 2/3. So 2/3 of the time he's going to lose. Brody would lose because he's going to get a 2 and I'm going to get a 3 every time, right? Okay, how about another? Take one more volunteer. Let that go with the right there. Now, you can all be thinking about what die you might pick. Suppose you come up and play that. Which one of these dice would you pick? You can pick any one you want. You can look at those or look at these. And once you fix the die, okay, you got one? No, she's picking. Okay. Okay.
Audrey picked a die with 3 5s and 3 1s.
Okay, she picked the orange one, this one right here. That one, this one right here. That's got 1s and 5s. Oh. I'm going to pick the red one.
She will be competing against the red die.
Okay. Will you go with a 3?
Audrey's 5 beats the 2.
She got a 5 and I got a 2.
Are you going to win 2 out of 3? She lost the second round.
She got a 1 and I got a 2. A lot of tension here.
Audrey won the third round and the match.
She got a 5 and I got a 2. The red is supposed to win 2/3 of the time, so I'm not having a very good day.
Don't play the lottery.
And Audrey was able to win, but she got lucky because I had a 2/3 chance of winning. If you look at it, 1/3 of the time I'm going to get a 6, right? So 1/3 of the time I'm going to win outright, no matter what she gets. No matter what she gets, if I get a 6, she's not going to win. 2/3 of the time I'm going to get a 2, and half of the time she's going to get a 1. So in that case, I'm going to win 2. And those fractions add up to 2/3.
In the handout, the 2/3 probability for the winning die will be explained. Here are some follow-up activities. These are the dice that were used in this video. The red die beats the orange die 2/3 of the time. The orange die beats the yellow die 2/3 of the time. The yellow die beats the green die 2/3 of the time. And what is surprising, the green die beats the red die 2/3 of the time. To help remember, red, orange, yellow, green, these are the first 4 colors of the rainbow. Red, orange, yellow, green. These dice can be formed from blank cubes. Let's use the faces of these dice to show these probabilities. The probability the red die will roll a 2 is 2/3. And the probability the orange die will roll a 1 is 1/2. The probability of both of these is the product 2/3 times 1/2. That's equal to 1/3. Also, 1/3 of the time, the red die will roll a 6, and this beats any number on the orange die. So we have 1/3 plus 1/3. 2/3 is a probability the red die will beat the orange die. Next, consider the orange die against the yellow die. The probability the orange die will roll a 1 is 1/2. And the probability the yellow die will roll a 0 is 1/3. And the probability of both of these is 1/2 times 1/3, that's equal to 1/6. Also, 1/2 of the time, the orange die rolls a 5, and that beats any number on the yellow die. So 1/6 plus 1/2, which is 2/3, is a probability the orange die will beat the yellow die. Next we consider the yellow die and the green die. 2/3 of the time the yellow die will roll a 4, and this beats any number on the green die. So the probability that the yellow die will beat the green die is 2/3. Finally, we consider the green die versus the red die. The green die always rolls a 3, and 2/3 of the time the red die rolls a 2. So the green die beats the red die 2/3 of the time. We have shown that the orange die beats the yellow die 2/3 of the time. And the yellow die beats the green die 2/3 of the time. So you might be tempted to conclude from this information that the orange die beats the green die 2/3 of the time. But the orange die and green die are both equally likely to win. Half of the time the orange die rolls a 5 and beats any number on the green die, and half of the time the orange die rolls a 1 and loses to the green die. So the probability the orange die beats the green die is 1/2. So just because one die beats the second die most of the time, and the second die beats the third die most of the time, we can't conclude that the first die will beat the third die most of the time. Because of this, these are called non-transitive dice. Here is an example of a transitive relationship. If a first number is greater than a second number, and the second number is greater than the third number, we can conclude from this information that the first number is greater than the third number. This is an example of a transitive relationship. In general, the greater than relationship is an example of a transitive relationship. As a final example, we know the red die beats the orange die 2/3 of the time, and the orange die beats the yellow die 2/3 of the time. But because these dice are non-transitive, we need to determine the probability that the red die will beat the yellow die. This is left as a homework exercise.